All right, so in the previous video, I explained linear and logistic regression at a high level. So now I want to go a little deeper and talk about what actually matters when you start building these models in practice, right? So a quick overview, right? In linear regression, we are typically predicting a number, predicting house price, sales, and revenue. Whereas in logistic regression, we are predicting the probability of an event happening. For example, the probability that a customer will churn, the probability that the lead will likely convert. So in linear, we are predicting a number, while in logistic, we are predicting the probability. Now at a high level, the process itself is actually fairly straightforward. So we define the response or the dependent variable, basically what we are trying to predict, and then define one or more predictor or independent variables, basically the inputs that may influence this outcome, right? So if you wanting to build this in something like an R or an R Studio, it's fairly simple. For linear regression, you use a function called LM, which is a linear model. And for a logistic regression, you typically use a function called GLM, meaning a generalized linear model, right? Conceptually though, the process is still the same, right? Load the data set, define the response variable, define the predictors, and then build the model, right? But honestly, building the model is usually the easier part. The more important question becomes which variables that we define are actually matter, because not every predictor variable contributes equally, right? So this is where the concepts of p-values become important, right? So at a very high level, p-value actually helps us understand which of the variables that we have picked are statistically significant to the outcome that we are trying to predict. So the simple way that people often remember is, if p-value is low, the variable is likely statistically significant. So if p-value is high, that means that variable might not really be contributing to the model as such. So now behind the scenes, there is something called null hypothesis and alternative hypothesis. Now these two concepts are very, very important if you want to build models, right? Null hypothesis usually assumes that there is no meaningful relationship, and alternative hypothesis, there is some meaningful relationship. So when the p-value becomes low enough, we reject the null hypothesis, which basically means the variable is statistically significant. So you have to pay attention here. Null hypothesis usually assumes that there is no meaningful relationship. So if p-value is low enough, we reject the null hypothesis, which basically means the variable is statistically significant. Okay, now there is another concept called R square, right? At a very high level, R square tells us how much of the variation in the response variable is being explained by the model. So generally, a higher R square means the model explains the data better, right? That does not automatically mean the model is perfect, but it just gives you an indication of the overall fit. Now, when we move into logistic regression, the focus shifts slightly a little, because now we are predicting probability and classification, right? So things like, will the customer churn, will the lead convert, will fraud happen, so on and so forth. So instead of focusing mainly on R square, we focus more on things like classification accuracy, prediction accuracy, precision and recall, and how well the model classifies outcomes. So, and typically when we create a model, we train the model using around 80% of the data and test it on the remaining 20%. And And usually you don't just build one model. You try multiple combinations, maybe with a full variable set, maybe with a reduced variable set, removing outliers, interaction variables, transformed variables, and then compare which model performs best. So honestly, in the real world, this is where model becomes both a science and an art, because it's not just about running a command, it's about choosing the right variables, understanding the relationships between the data, removing noise, testing accuracy, and making sure the model reflects real world behavior. So the key takeaway here is building a regression model is technically it's easy, right? But building a good regression model is where the real work happens. And usually that comes down to variable selection, statistical significance, validation, and the model accuracy. So this is what turns a mathematical model into something the business can actually trust and see. So you see, anybody can run a model. The real skill is knowing whether the model actually means something, and when you put it in practice, it is producing the desired results.